Good morning and good afternoon, everyone. I'm Zhang from the Hong Kong Polytechnic University. I now serve as a research assistant professor at the Department of Building Environment and Energy Engineering. It's my pleasure to have this chance to present my research. Actually, this is my third time to participate in the Fire and Evacuation Modeling Technical Conference. The first time is during the COVID-19, and it is an online sharing. And the second one is in Brno, Czech Republic, a very beautiful and impressive country. And the third time, due to the teaching duties, I have to do it online, but I still feel excited to share some of our recent research about firefighter safety in fire with you. The presentation will be like those 4 parts, some background, and I will introduce some previous work on firefighters last year, and then we have some new research. We did a survey and the results of firefighters' safety and their decision making. And the last part is we classify the firefighters based on their decision making preference. And we all do fire-related research, human behavior in fire research. We all are aware of the threat of the fire accidents, especially when we are building higher skyscrapers and we have deeper underground spaces treated as shopping malls or subway stations, and also the high density of occupants, so that those when there is a fire, the evacuation scenario could be very complex, and self-evacuation by occupants may not be sufficient. So we still need the intervention of the firefighters to help us. However, we do not pay enough attention to the firefighters' safety issues. For example, in one fire, mini storage fire in Hong Kong in 2016, there was no occupants injury, but we have 2 firefighters deaths and 11 firefighters injury. And also in another fire, the City Library in California in 2020, we also found 2 firefighters were dead when battling a fire. So the second part, I will introduce our previous work on firefighters. This is a work we finished last year, and we proposed the safe firefighting time. It's the time to evaluate the firefighters experience either short-term injury or long-term injury, either physical or mental. And this definition is proposed along with the definition of safe egress time for the occupants, and we define it with their task, timeline, moving paths, and evacuation. And then we propose the definition of the ASAFT, available safe egress time, from the fire ignition till the time slap when the whole environment is untenable for firefighters. And we also propose the RSAFT, the required safe firefighting time, composed of the time traveling to fire, do the firefighting, and rescue. And the ASAFT should be larger than the RSAFT so that we could make sure our firefighters are safe. And in this study, we gave the ASAFT criteria following the reference value of the ASAFT. We divide them into 2 parts, the principal ones, composing of temperature and thermal radiation, and the threshold is upgraded from 60 degrees to 80 degrees and 2.5 kilowatts per square meter to 5. And also we have the secondary criteria with the visibility and the carbon monoxide, considering the firefighters have their professional suit and facilities. And we also give the equations for the RSAFT, composed of different tasks, such as they arrive at the fire scene, they do their assigned firefighting task, and they move out of the buildings. And they consider the movement time, their duties, the cooperation among groups, and also the burden they carry. And with this definition, we want to contribute maybe an upgrade or update of the current safety design rules from the A set should be larger than the R set, like this. For example, the R set could be modified or shortened with the intervention of firefighting, and also we have to pay attention to the A set should be larger than the R set. So this is the previous work we do about the firefighters. And during the investigation, we found that decision-making of their firefighters, the own firefighters, play a primary role to ensure their safety. They have to rely on themselves. In this corner, okay. So we want to find out how decision-making will influence firefighter safety during operations. Will they rely on the real-time or the external fire scene to make their decision-making, or they will just stick to their own protocol or the thoughts? And we want to explore the impact of the safety awareness on the firefighters of their adaptability to make their decision. And then we want to classify firefighters based on their decision-making preference. So here is the framework, and we will take a detailed look. Here. So we want to investigate the firefighter safety in fire, especially their decision-making. We want to know what factors will affect the firefighters to make their decisions. Firstly, we have the safety awareness composed of experience and preparedness. And experience is an initial quality or characteristics such as age or years of service. And also we consider education or injury history. And the preparedness or preparation is the work the firefighters do to the targeted fire scenes, about how they understand or how they know about the fire, such as the route to the fire, or the building layout, or the fire characteristics. And for the decision-making, we have three scenes: the three firefighting operations, fire suppression, locating trapped individuals, and withdrawing with the trapped. And then we want to investigate, for each firefighting operation, what external factors will affect the firefighter's decision-making, such as the distance to the fire source, the fire density, smoke density, etc. And first, we collect the data from over 100 firefighters in several urban fire brigades. And for the gender, they are all male for their workload. And for the years of firefighting, around 70 of them have experienced less than 5 years, which could be regarded as freshmen. And for the previous safety issues, around 30 of them experienced either minor or major injury. And then we do the data analysis for all the results of the firefighters about their survey. First, we collect data, and then we do the measurements model to test if each question could represent the construct. And then we do the model fit estimation, and then we do the structure equation model to analyze the relationship among each item. For the step 2 measurement model, we want to test if each question, such as each external factors, could represent the construct, such as the decision-making in fire suppression. So we do the data analysis, and we use those indicators to evaluate, such as the factors loading, composite reliability. And then we have the threshold, like most are 0.5, and this composite reliability is 0.7. And we have the results for all those 5 categories, from experience to withdrawing, and all the results show that each question in each construct could present the construct well. And also we do the discriminant modality, and also it shows that it's good. And the third step, we do the model fit estimation to determine the accuracy of the model. We use the goodness of fit point with the result of 0.453, larger than the threshold, showing large goodness of fit. And we also do the SRMR, signifying a more good model fit. And step 4 is the most important one to give us the results, to analyze the relationship among each item. For example, we want to know if more experienced firefighters, they will do more adaptive decision-making. That is to say, rely highly on those external factors when they do the fire suppression, which is good or which is safer for them. And we investigate those 6 relationships, and we have this results. Yes, the more experienced firefighters, they will do more adaptive decision-making during fire suppression. But a more experienced firefighters, we do not find the results leading to a more adaptive decision-making when they locating the traps. And for the preparation, all 3 of them show a positive influence on all 3 tasks. Well, some of them are positive, but some are more medium positive. With these results, we want to further analyze or classify the firefighters based on their decision-making preference. We first do a clustering analysis based on k-means. We have 22 external factors or questions for all firefighters, and we want to visualize or divide them into different clusters. So first, we reduce the 22 dimensions into 2 dimensions. And so here is the result. Then we could divide them into 3 clusters, and each cluster have different numbers of firefighters. And then we want to know, are there any common rules or the performance of 3 clusters? And then we investigate the impact of their answers, whether they will be influenced by the external factors of the decision-making among all 3 tasks. And based on these results, we define them into 3 categories. The first is adaptive fighters, occupy among 50%. We could see they are influenced highly by these external conditions, which they evaluate them as 5 score the highest. For the average, for the second cluster, we define them as the average. They are influenced by the external conditions from medium to highly. And the last one, we call them the rigid firefighters. They are influenced medium or less by external conditions. Furthermore, we want to investigate whether there is a relationship with the clusters of 3 clusters with their works of service. So we do this pie chart, and we found that over 10% of firefighters in adaptive type has more than 10 years of experience, which is the highest percentage. And the rigid group have a higher proportion of less experienced firefighters, from 2 years to 5 years. And an interesting phenomenon is all the new recruits, which is less than 2 years of service, they rely highly on external factors. So that it means they are very fresh and they have less experience, so that they have only to rely on the external factors. And also we do the classification of firefighters with their previous safety issues. And we found that the rigid age group has a higher proportion of injuries than other two clusters. And the adaptive group are the safest with the least injury. The last thing we do is we want to find the classification of the three clusters and the relationship with the preparedness. And we found that for the adaptive firefighters, they are generally very familiar with all types of fire-related information, while the average firefighters, they display a range of made familiar to very familiar. And for the rigid firefighters, they have a broad range from both unfamiliar to very familiar. And I'm going to wrap up the study. We collect 129 firefighters' response to the decision-making factors, and we found the experience is a double-edged sword to the adaptive decision-making for different firefighting operations, while the preparation shows strong positive effect across all tasks. And based on that, we divided the firefighters into three clusters: adaptive, average, and rigid. This is just a preliminary summary of our research, and welcome to questions, comments, and suggestions and discussions. Thank you very much.